Okay, hi guys. So in this lecture, we'll be seeing the second type of nucleophilic substitution reaction, namely SN1 reaction. Okay, SN1 reaction. So let's have an example. Let's understand this with the help of example. We have this and this on a polar protic solvent converts into this. So we'll look into the mechanism of as to how this reaction happens and what are the characteristics of this reaction in a short while. Okay, so the mechanism goes as follows. The compound first, this is the redetermining step, first converts itself into a carbocation with the Br minus leaving the compound, and then this compound on reacting with the polar protic solvent, this H2O attacks the carbocation to form or rather R2 and R3 here. Okay, now it again reacts, again H2O molecule attacks on this compound to take off the hydronium ion from this compound, and plus Br minus was also released from the first step or the RDS. Okay, so this is the product formed finally from the SN1 reaction. So what more happens is we also have something like this R1 R2 R3. The hydronium ion actually what happens actually, I'm just trying to make a bigger picture from this. What actually happens here, that the hydronium ion, the H2O molecules surround themselves with this to extract the H from the molecule, and on the other hand, at the same time, the Br minus which was released from after this, Br minus was released, so Br minus was also being hydrated by the water molecules. Okay, so talking about the RDS, so the breaking of this bond between R plus and Br minus lies the whole reaction. Okay, the cleavage of this bond is the RDS. Okay, so let us talk about the characteristics of this reaction. So the first characteristic is rate is proportional to the concentration of the halide and halide only. That is why it is called SN1 reaction. It is unimolecular. Okay, so it is proportional to the concentration of halide. The second point is rate is independent of the concentration of nucleophile. Means nucleophiles role in the reaction is to play after the carbocation is formed, and which is not the redetermining step. Okay, so the formation of carbocation was the redetermining step. After that, whatever may be the concentration of nucleophile, it doesn't matter. So rate is independent of the concentration of nucleophile. Okay, the third point is formation of carbocation is the rate determining step. So hence, more the stable carbocation, more is the rate of reaction. Formation of carbocation is the rate determining step. Hence, more stable cation, more is the rate of reaction. And the fourth point is rearrangement is possible in this reaction because unlike in the previous reaction, which was SN2, the addition and breaking of the bond was happening at the same time, and that was the RDS in that case. But in this case, or the SN1 case, rearrangement is possible because carbocation is actually formed as the first step of the reaction, and which is the rate determining step. And in the second step, the attack of nucleophile actually happens on the product of the first step, or the intermediate product, which is carbocation. Hence, it gives them ample space to have a rearrangement possible in the reaction. Okay, so rearrangement is possible in this reaction. Fifth point is solvation energy will convert with activation energy. So I'm not writing the big buzzy words until I go on to the inorganic lectures, but it's not a very big characteristic to be remembered here, so I am not writing it. So polar protic solvent favors actually SN1 reaction. Polar protic solvent favors SN1 reaction. Sixth point is leaving group will affect the rate of SN1. Okay, so with this we come to an end of this lecture. In the next lecture we'll be comparing the rate of SN1 reactions in the compounds. So till then, good luck and goodbye.